Students, today we are going to discuss the fluid mechanics in physics. Now, fluid mechanics is a chapter that deals with the fluid which is in motion. It is the chapter that deals about the motion of a fluid. Okay students, now first we are going to discuss about the fluids which are in rest, and again we are going to discuss about the fluids which are in motion. Now in this chapter we are going to discuss fluids at rest and fluids at motion. Now, in the first part of this chapter, we are going to discuss about fluids at rest, and in the later stages, we are going to discuss the fluids at motion. Okay? Now, we are going to discuss about fluids at rest. Now, the fluids at rest has pressure, density. It has pressure and density. Okay. Now we are going to discuss about pressure. Okay. Pressure. Now pressure states that, first suppose it is an object having area A. Now the force applied. Now for example it is a duster having area A and we apply the force F. So the pressure will become force upon area. It is the force. So it will become F external upon area. It is the formula of the pressure. Now we have gauge pressure, atmospheric pressure and absolute pressure. There is a relationship between these three. Now gauge pressure is equal to absolute pressure minus atmospheric pressure. Now in liquids, liquids flow, liquid pour in a container. It is the liquid having the particles. It is one particle and it is one particle. The pressure can exert between two liquid particles or with the wall of the containers, Now due to this high pressure of the liquid on the bottom surface shall break, but it is not occur because the bottom surface same pressure as that of the liquid. So here Newton's third law will applicable. Now the bottom surface, should break, but it does not happen because due to but breaks due to the downward force by the liquid molecules, but it is not correct. Now, in our daily experience, if you pour liquid in a glass tumbler, the bottom surface of the tumbler is not break because the downward force exerted by the liquid molecule on the bottom of the container and the F upward force by the bottom surface of the container is same. It's not correct because F downwards is equal to F upwards. So for this reason the container is not breaking in all the cases of our daily life. Okay students, now there is an important point that important conventions. Now the pressure can be measured by absolute manometer and the barometer. Pressure can be measured by manometer and barometer. Okay students, the pressure can be measured by barometer and manometer. Now we will discuss about manometer and barometer after reading the density topic. Okay. Now there are two cases in the pressure. We will discuss about the pressure cases. Have you copied students? Okay, I am going to rub this. Okay, now we are going to discuss about cases. The first case is if we have the containers having different shapes. This is the container and this is the container or the container of irregular shape. Okay, now the pressure at the same height surface, the pressure at same H, here also H, A, B, C. Now at the same height surface, the pressure of A is equal to pressure of B is equal to pressure of C. The pressure will be same, but the weight cannot be equal. WA is not equal to WB is not equal to WC. Okay. Now there is a second case. Um, okay, we will discuss about second case. A container is filled with liquid. Up to the top side. Now, we want to find the pressure here. Here we want to find the pressure. It is having height h. Now at the top side, atmospheric pressure is occurring, and and the liquid also exerting pressure. The pressure is rho g h. We will discuss about rho g h after reading the density topic. So pressure at bottom is equal to pressure at atmospheric plus rho g h. It is the simplest case. Now there is another subtopic here. It is A. Now if a block of mass m is placed placed here. Now you want to find the pressure here. Now its weight is mg. Now it has a force. It has an area A. So okay, P is equal to, for instance, due to the small size, I will not bring this. PB at the bottom surface is equal to P naught. It is the same as this, but we want to add this. Due to this, we want to addition this term with rho g h plus it has the force mg here, having the area A. It is the simplest formula because due to this. Now we have another case that a cylinder of height h is placed a cylinder of height h. Yes, it is h. The distance from top is up to here is h1 and up to here is h2. The distance and the distance h1 and here is h2. Now you want to find the pressure at here. Now the height is h2 my h. For instance, 1 minute. Okay students, now the case is we want to find the pressure. The pressure is so easy. We want to place h as h2 minus h1. It is the simplest. P is equal to P naught plus rho g into h1 minus h2. It is the case. Okay. Now we have discussed about pressure cases. In this first case is at the same height level the pressure is same. We will apply this case in the future topics of this chapter. Now of the second case, at the bottom of the surface the pressure is P naught plus rho g h. If in the same liquid a mass of block m is placed here having the area A and the pressure is mg, the pressure at the bottom surface is Pb is equal to P naught plus rho g h plus mg by A. Now at the second case is a cylinder having mass height m. Now this is it is the difference of the pressure delta P. Sorry students, it is delta P. Now at the top of the surface the height is h1 having the pressure P1 and the bottom of the surface is H2 having the pressure P2, then the change in pressure is this case. Now we have discussed about the pressure. For the fluids at rest, now we are going to discuss about the density. Now we are going to discuss about density. Density. Okay. Density says that mass upon volume gives the density. Is the formula we have discussed so many times in the chapter, in the physics course, or you have read in chemistry. Mass upon volume. It is the formula for density. Density states that for a unit volume, as the mass occupied by 1 kg mass gives the density is 1 kg per meter cube. Use the density. Now we have relative density. Relative density gives to water. We will compare with the water. It is density of fluid or substance upon density of water at 4 degrees Celsius. Students, we have taken the density of water at 4 degrees Celsius because the density of water is maximum at 4 degrees Celsius and the value is 1000 kg per meter cube. We will write here density of water at 4 degrees Celsius is 10 cubed kg per meter cubed. Okay students, now we are going to discuss about the mixture of liquids or fluids. Mixture of fluids. Now we have two cases in this. Now if we have, it is M1, M2 having V1, V2 and the density is ρ1 and ρ2. After combination, the mass will become M1 plus M2 and the volume will become ρ1, V1 plus V2 and the density will become ρ dash for suppose. Okay, now as we know that the ρ dash is equal to, for the mixture it is M1 plus M2 upon V1 plus V2. Okay, now we have two cases in this. Case 1, if M1 M2 is not given, if M1 M2 not given, then we want to find the ρ dash. Ρ dash is equal to dash. Now as you know, M1 is equal to M1 is equal to ρ into V1. That is ρ1. Now M2 is equal to ρ2 into V2. In the place of M1 we can place ρ1 V1. In the place of M2 we can place ρ2 V2. Now we are going to substitute here ρ1 V1 plus ρ2 V2 upon V1 plus V2. Now we have the case that if V1 is equal to V2 is equal to V. V1 is equal to V2 is equal to V. Then rho dash is equal to, we will take the common V. V into rho 1 plus rho 2 upon V into 2. Sorry students, here rho dash, here rho. Now the final density will become rho 1 plus rho 2 upon 2. Okay, now we have the second case, case 2. Okay, if V1, V2 is not given. Now from the density formula, we can substitute volume is equal to mass upon density, or m upon rho. For V1, okay, for V1, m1 upon rho 1, for V2, m2 upon rho 2. Now the rho dash is equal to m1 plus m2 upon m1 by rho 1 plus m2 by rho 2. It is the formula. Now we have the case. If m1 is equal to m2, okay. Now rho dash is equal to, m plus m gives rise to 2m. 2m divided by, in the place of m1 and m2 we can substitute m into 1 upon rho 1 plus 1 upon rho 2, and they both will be, here mass will become cancelled. 1 upon rho 1 plus 1 upon rho 2 gives rise to rho 1 plus rho 2 upon rho 1 rho 2. We will write this, rho dash is equal to 2 upon rho 1 plus rho 2 upon rho 1 rho 2. Okay, 2